Sometimes in an algebra question you'll be simply given some algebra, an expression which needs to be simplified, and the instruction will simply be simplify, and that's it. That as it stands is just an algebraic expression. It's not an equation. You haven't got something is equal to something, hence find what x is. That is just some algebra and you're asked to simplify it. Now for some of the harder ones which appear towards the back of the harder paper, the technique basically involves you recognising, and you won't be told this, so you've got to be able to spot this yourself, that you have to factorise somewhere in the question before you can simplify it. So if I take you through some examples like this to show you what I mean, sometimes you'll be asked to factorise something like that. Now, you've got to realise how you can simplify when you've got a complicated expression like that. What I'll do is I'll take you through exactly what you're supposed to do, and then afterwards I'll tell you what you're not allowed to do, because sometimes what you're not allowed to do is what most people are tempted to actually try doing. Okay, this is what you're supposed to do. I'm going to leave the bottom line exactly unchanged, so the x plus 4 on the bottom unchanged. I'm not going to change that. And the top line, I'm going to look at it and say, how could I change that? How could I simplify that? One of the things that you should know is if you've got a quadratic expression, x squared plus 4x, you can factorize quadratic expressions. So you should ask yourself, can I factorize this? And the answer is yes, because it's got a common factor. And that's the first thing you should always ask yourself if you're trying to factorize. Has it got a common factor? Yes, it has. The common factor is x. And so you take out the x as a common factor, and the rest goes inside a bracket. So you say x times what gives you x squared? Well, it must be an x. And then x times something gives you plus 4x. And the answer must be plus 4. Like so. So you get the top line being x times x plus 4. And the bottom line is x plus 4. Once you get to there, you should now look out for cancelling. When you have got something times by something divided by something, you can cancel things. Now I hope you can see that there's an x plus 4 on the top and an x plus 4 on the bottom. So what I'm going to do is share the bottom by x plus 4, it goes once. I'm going to share the top by x plus 4, so that becomes a 1. So what you're left with is simply x times 1 on the top, which is x, all divided by 1, which of course is just x. And there's the answer. So that nasty looking expression there is actually the same as just x, which of course would be much easier to use if I was using that in a harder problem. Okay, now I can see some of you might or might not be very confident about that cancelling there. Let's go back to the beginning again, and a lot of people might be tempted to do something like this. They might say, well, there's an x on the bottom and there's an x on the top. You've got a big fraction there, so we can cancel x's. You might be allowed, you think, to say, let's share that by x, it goes once, and share that by x, it goes once. And that's what a lot of people would be tempted to do. And then, on top of that, you might compound that error, because that's not right, by doing this afterwards. Share the 4 by 4, it goes once, and share that 4 by 4, it goes once. Well, you can quite clearly see, if you do that process, you end up with x squared plus 1 on the top line over 1 plus 1 is 2 on the bottom line. And quite clearly x squared plus 1 over 2 is not the same thing as x. Now, some of you might say, well, okay, I sort of get that, but I think you might understand it better if I actually do some numbers instead of x's to see why you can't do that and why you have to do it this way. So for example, if I have 2 plus 4 all over 1 plus 2, like so, then the answer to that can be found in two different ways. You can either say 2 plus 4 is 6, 1 plus 2 is 3, so it's the same as 6 shared by 3, so the answer is 2. So the answer to that is 2. Now what a lot of you might be tempted to do is say, right, let's try cancelling it. Share that by 2, it goes once, share that by 2, it goes once. And you might think, okay, I can do that. Well, if you now work it out, I've already worked it out, the answer should be 2. So if you cancel those 2's like that, you'll find that the answer is 1 plus 4 is 5, 1 plus 1 is 2, so the answer turns out to be 5 shared by 2, which is 2.5. Well, we know the answer should be 2. And that cancelling technique there gives you an answer 2.5. So what that tells you is you're not allowed to cancel like that when you've got a fraction. The basic rule is, if you've got numbers added together, top and bottom, or perhaps if they're takeaways, it's the same principle, you're not allowed to cancel one number on the top with one number on the bottom. It doesn't work like that. So I'm not allowed here to cancel that x with that x there. It doesn't work. It's not allowed. What you are allowed to do, though, is something like this. If you had 2 times 3 over 3 times, say, 5, like that, okay, what you are allowed to do is to share that number by 3, it goes once, and share that number by 3, it goes once. That is allowed because we're multiplying numbers. That is okay. Let me just check it's okay. 2 times 3 is 6, 3 5s are 15. The answer is 6/15ths. But that'll cancel to 2 over 5 if you share by 3. Now, by cancelling, can you see, you get 2 times the 1 is 2, and 1 times 5 is the 5. So by actually cancelling the 3 and the 3 there, you are allowed to do that because it does give you the right answer, 2/5. You're not allowed to cancel when the numbers are added together, top and bottom. 2 and 2 do not cancel in that case. That would be the wrong thing to do. So you're not allowed to cancel x and x, you're not allowed to cancel 4 and 4, that's not allowed. But what you are allowed to do, once you've factorised it, can you see you've got a number times by another quantity, you've got a quantity times another quantity, a quantity times a quantity, all over another quantity. So it would be like, let me get rid of that, it would be like 2 times 3 all over 3, and I'm cancelling the 3's, I'm cancelling these brackets. It's something times something over something, something times something over something. You are allowed to cancel like that. That is okay. And that's why the brackets will disappear to give 1 and 1. Share that by x plus 4, it goes once. Share that by x plus 4, it goes once. So you get x times 1 all over 1. So that's the reason why you're allowed to do it. Okay, now if you didn't quite grasp that, perhaps you should replay this video and watch through that explanation again. And if you still don't get it, then just ask me and I'll record another video, or I'll sit you down myself and we'll talk through the logic of why you're allowed to do it there, but you're not allowed to cancel like that. Okay? So, if I now do another example, number 2 of these simplifying fractions, let's speed up now. Okay, so number 2, let me change my pen because that seems to be running out. Okay, number 2, here we go. This time I'm going to have 2x squared minus 6x all over x minus 3, like so. I've got to simplify that. So what I'm going to do is realise the top is a quadratic expression. Quadratic expressions can factorise. So ask yourself, does it have a common factor? Yes, it does. Common factor is 2x. The rest goes inside a bracket. 2x times x gives you 2x squared. 2x times a negative 3 gives you minus 6x. All over, and the bottom line, well, I'll put it in a bracket now. It wasn't in a bracket in the original question, but you're entitled to put it in a bracket. It's all over x minus 3. Okay, I've got something times by something over something. That can be shared by x minus 3. That can be shared by x minus 3. So in other words, the two brackets cancel. This leaves you an answer of just 2x, and it's as simple as that. And that sort of question in the exam would be worth about 3%. Okay, let's try a slightly harder one. Let's say you had x squared plus 5x plus 6, and on the bottom line you had x plus 2, like so. You've got to simplify that. Okay, looking at the top line there, I can see that the top is a quadratic. So let's actually factorise the top line. This here does not have a common factor. Right, next, does it have a difference of 2 squares factorisation? Well, it's certainly not the difference of 2 squared terms, so it's not that. Is it easy table method? Yes, it is. So I'm going to be able to factorise, because it's only 1x squared, into 2 brackets and leave the bottom line alone. Okay, now to get the 2 brackets, because it's x squared, it must be x and x. And then to get the 2 numbers, what you need to do is set up a table. Now I haven't got any space at the side, so I'll do it here, with a times and a plus sign. Underneath the times sign will be the positive 6, and underneath the plus sign will be positive 5, like so. So I'm looking for 2 numbers that multiply to give plus 6, but add up to give plus 5. Well, plus 3 and plus 2 multiply to give plus 6, and they add up to give plus 5. So the 2 numbers are plus 3 and plus 2, like so. So on the top I've got something times something share by something. That means I can share the top by x plus 2, it goes once. Share the bottom by x plus 2, it goes once. And so you end up with just an answer, x plus 3. Okay, you could put it in a bracket if you want, but if I'm not multiplying it by something or dividing it by something, I don't need to put the bracket in. X plus 3 is the answer. That was question number 3. Okay, a couple more. Question number 4. How about x squared minus 16 all over x squared plus let's say 5x plus 4. Okay, that looks quite nasty. Temptation, if you don't know what you're doing, is to say, right, I can cancel x squared with x squared. No, you can't. Not when things are added or taken away top and bottom of a fraction. You can't do that. You can only cancel one term with one term when they're multiplied together on the top or on the bottom. So the first thing you've got to do is actually factorise these quadratic expressions. Top line, does it have a common factor? No. Is it the difference of 2 squared terms? Yes, it is, because it's x squared take away 4 squared. So this becomes x plus 4, x minus 4 on the top line. That's the difference of 2 squared terms, x squared minus 4 squared. All over. Bottom line, will it factorise? Well, has it got a common factor? No. Is it the difference of 2 squared terms? No. Is it easy table method? Well, probably yes. X and x, it's 1x squared, so at the side here, times and plus. Plus 4, plus 4, plus 5, plus 5. Well, plus 4 plus 1 multiply together to give plus 4, and they add together to give plus 5. So plus 4 plus 1. Now you have 2 things on the top multiplied together, 2 things on the bottom multiplied together, so you are allowed to cancel one of them on the top with one of them on the bottom. So share that by x plus 4, it goes once. Share that by the same thing, it goes once. And so you're just left, well, those 2 don't cancel, and you can't cancel just the x with just the x. It doesn't work like that. It's either the whole bracket or nothing. You can't cancel just one of the terms. So you're left with 1 times x minus 4, which is just x minus 4 on the top, over 1 times x plus 1, which is x plus 1 on the bottom. And there you go, there's the answer to that question. That simplifies to that. They are the same thing mathematically. Let's try another one. Get rid of this. So number 5. Okay, so for number 5, how about let's say we've got number 5, 3x squared minus 7x on the top, and on the bottom line we're going to have 2x squared plus 6x, like so. And you're going to factorise that. You're not allowed to cancel off the x squared, share by x squared, share by x squared. Not allowed to do that. You're not allowed to share by x, share by x. Can't do that. You can't share by 3, share that by 3. Not allowed to do that. So what you're going to do is factorise. Top line, is there a common factor? Yes, there is. Common factor is x. Inside the bracket, 3x minus 7. So there's the top line factorised. Underneath, factorise. Is there a common factor? Yes, there is this time. There's another common factor of 2x. So take out 2x as a common factor. 2x times x gives 2x squared. 2x times plus 3 gives you plus 6x. So we get to there. Now the top line, you can see we've got now two things multiplied together. So it's like having 3 times 2 on the top over. The bottom line, you've actually potentially got three things multiplied together. You've got the 2 multiplied by something else. Okay, you might have a 7, say, multiplied by something else. That might be, say, 11. So it's actually 1, 2, 3 things multiplied together. Well, all that means is that I can cancel, say, that one there, share by 2, with that one there if I wanted to. That is allowed. Now in this particular case, what I'm going to do is cancel this one here, share that by x, with just that one there, share that by x. So I'm cancelling the x and the x. That is allowed. It's like sharing, well, if I gave you another example, let's say it's 5 times 3 over 2 times 5 times 7, then what I'm doing is I'm cancelling that one with the second one. So it's like cancelling 5 with 5 there, and 5 into 5 there. So it's like cancelling those two. That's allowed, that's okay. So you can do that, that's fine. So the answer is 1 times 3x minus 7, 3x minus 7, all over 2 times x plus 3. So you'll have two lots of x plus 3 on the bottom. And that's the end of the question. Okay. Number 6, last one. Let's make this as hard as I can possibly make it. So number 6, let's say we have x squared minus 3x minus 4 on the top, and let's say if I just do a very quick calculation to make sure the bottom line is going to work out nicely. Okay, let me just do this quickly. It's 2x squared minus 7x minus 4, like so. Let me just double check that I haven't made a silly mistake. That looks okay to me. So we're going to factorise top and bottom of that before we can simplify it, and then we can cancel things. So the top line, factorise, no common factor. Difference of two squares, no. Okay, easy table method, yes. It's going to go to a double bracket with x and x. Fine. So easy table method, times and plus. Okay, times, underneath the times sign is minus 4, underneath the plus sign is minus 3. So we get that. So what we need to do now, two numbers that multiply together to give minus 4 plus 1. Add them together, they do give minus 3. So minus 4 plus 1, there you go, there's the top factorised. Bottom line, common factor? No. Difference of two squares? No. Easy table method? No. So what I'm going to have to do is the hard table method. Now that means I'm going to have to factorise this by the hard table method, which is actually quite tedious. So what I'm going to do is just do a side factorisation. Let's write this out at the side and we'll go through the hard factorisation technique for the hard table method. Leave the 2x squared alone, and we're going to rewrite the minus 7x as two quantities instead of it. So I need to draw another table, times and plus. Underneath the times, 2 times minus 4 is minus 8. Underneath the plus is minus 7. So 2 times minus 4 is minus 8, minus 7. I'm looking for two numbers that multiply to give minus 8, but add up to give minus 7. It's going to be minus 8 and plus 1. They multiply to give minus 8, and they add up to give minus 7. So I'm going to replace the minus 7x with minus 8x plus 1x, and then minus 4. And then if you remember what we do, we take the first two terms and we use common factor of 2x on them. 2x times x, 2x times negative 4. That gives you 2x squared minus 8x. Then we have the second two terms. We do the same sort of thing. Now remember, inside the bracket we get is going to be exactly the same as the x minus 4 here. So that means we can now easily write down what goes there. Well, if you think about it, it's going to be plus 1, because plus 1 times x gives plus 1x, plus 1 times minus 4 gives you minus 4. So that is the correct line at that stage. Now we say we've got two terms, and in each term we've got an x minus 4. So that is a new common factor. X minus 4 times something gives you all of that. The something must be 2x. x minus 4 times something gives you all of that. The something must be plus 1. So there you go. The factorisation for the bottom line now is x minus 4, 2x plus 1. So x minus 4, bracket 2x plus 1. And at this stage you can see we've got an x minus 4 top and bottom. So share that by x minus 4, share that by x minus 4. You can't cancel x and x, you can't cancel 1 and 1. That is not allowed. So the answer turns out to be x plus 1 on the top, leave it in a bracket, bracket times 1 is just the bracket, and then 1 times the bracket on the bottom is 2x plus 1. And there's the answer. Again, do not cancel 1s, do not cancel x's, it's not allowed. There you go, 6 examples, number 6 definitely the hardest, on how to simplify using factorisation techniques.